Hello, everybody. We're going to get started now with the next chapter, which is chapter 5 in our Wildy textbook, and it is called DC Motors. And we're going to explore DC motors. But the beauty of this chapter is that same machine that we were looking at in chapter 4, that we called a DC generator, is built the same way. And so all we're doing is we're taking this DC machine that in chapter 4, we were supplying mechanical energy to it, and we were outputting electrical energy. Now, we're going to reverse that, and we're going to supply electrical energy to this same machine, and we're going to output mechanical energy at the motor shaft, which we can use, by connecting different loads to it. So we really don't have to go into any additional detail about the internal construction of the machine. All we're going to do now, we're going to look at just what changes and how we supply that electrical energy to that machine. So let's look into this. So the DC machine and the DC generator and the DC motor are basically the same. The only thing is how we connect this and what we're connecting to it. Internally, we got the same machine providing a different function. Electrical energy in, mechanical energy out. And so this is what we're going to focus on in this chapter. We're going to throw some things out here probably for the first time, but he talks to us that these DC motors have something called a torque speed characteristic. Now, we'll go into a little more detail about what that means later, but we have discussed what torque is. And of course, we understand the idea behind speed. And so what you do with a particular motor and a particular motor type is you can adjust the way that this motor operates based on the load that you connect to it. Now, some loads, the primary consideration is the torque that you may need, or the combination of the torque and the speed, in the particular application. So, a pump or a fan is going to operate one way. A hoist, that would be bringing up a heavy load would be acting a totally different way. And what we'll see as we go through now with these specific machines is we'll look at characteristic torque speed curves, okay? And each motor, each AC and DC motors, they'll have a characteristic curve that is typical of that particular motor. And what we want to be able to do is to match that to applications. That's where our usefulness comes in on this. And so when you're matching a DC motor to the load, it has led to 3 types generally of DC motors. There's a shunt, a series, and a compound. And again, doesn't that sound very familiar? Isn't that the same things that we talked about when we were talking about DC generators? Now, for the most part, DC motors it's a specialty application because of the fact that the supply available to operate electrical machines is AC. So for there to be this DC application, it requires a conversion and availability of this DC current to be able to operate the machine. So it's specialty applications. You're looking in steel mills and mines, electric trains he mentioned, and those applications will have certain characteristics that we'll explore that make them applicable to DC machines. One reason he mentions is the torque speed characteristics of DC motors can be varied over a wide range and at the same time maintain a high efficiency. Now, that statement in and of itself should be enough to say that DC motors are particularly useful in particular applications, but something that will come up again and again is this idea of an AC drive. And an AC drive, and we'll talk about this throughout the rest of the semester, allows us to do many of the things that we used to could only do with a DC machine with an AC machine. And just the real quick version of that is that you can take an AC input, you can rectify it, convert it to a DC, and then apply it to whatever the application is. So anyway, we'll get into that in greater detail as we go forward. Nevertheless, there are, he says, millions of DC motors that are still in service, and that thousands are still being produced. So we're going to spend this chapter 5 investigating these machines to some pretty good detail.